Hello and welcome again to the Kaloran Classroom. Today we are discussing a very important topic. It is Lesson 78, Products of Squares. We have discussed this before and you guys have had some difficulty with it. So we just need to recall some of the rules. We have learned about simplifying radicals. So here's an example of a radical right here. We are going to simplify it right now. So take out your pencils. Make sure you stop the video and try to simplify it on your own before Mrs. Kaloran does. If you did so, you should get this answer. The square root of 32 can factor out, and we can factor it into 8 times 4. And then we can factor it again into 2 times 4. 2 is prime, so circle it. We can factor 4 into 2 times 2, which are both prime, so we circle both of them. 4 times 4 can also be factored into 2 times 2, which are both prime. So if you look at the square root of 32, we could also think of it as the square root of 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Always check to make sure you have the right number. 1, 2, 3, 4, 5 of them. Okay? Remember, after we took and found all of the prime factors, we then took out groups of 2. So here we would take a group of 2. Here we would take a group of 2, and we have a lone one. That's sad. We can't do anything about it. I'm sorry, you guys. We would end up with, if we had this square root of 2 and square root of 2, the square root of 4. Square root of 2 and square root of 2, which is the square root of 4, and square root of 2, which is the square root of 2. Now, keep in mind that each and every single one of these is getting multiplied. And you guys should know, since at least 7th grade, that the square root of 4 is 2, times the square root of 4 is 2, times the square root of 2 is the square root of 2. Can't simplify it. Sorry, we don't know it. 2 times 2 would then simplify into 4, and you would be left with this simplified, we call it simplified radical form. No ifs, ands, or buts about it. This is simplified radical form. So the big thing we're going to be talking about and discussing today is this step right here. Is that the square root of 4 times the square root of 4 could also be looked at, okay, I'm just going to circle both of those. Square root of 4 times the square root of 4 could be looked at as the square root of 16. And do you know the square root of 16? Yes, you do. It is 4. Okay, so that's just our new material we're going to be looking at today. So let's dig deeper. We can also multiply radicals, okay? So that's what I was just talking about there. We are going to find the area of the figure below. So in order to find the area of the figure below, what do you think your first steps might be? Well, if we want to find area of a rectangle, we would need to know side length. Okay, we need to know a length and a width. And in order to find the length and the width, what are we going to do? Oh, it is ugly. I know. But we got to figure out how to do it. So we are going to create the only figure we can possibly create, which is a right triangle. And with that right triangle, you guys can see that from here, 1, 2, 3 units is our measure. And from here, 1, 2, 3 units is our measure. This should tell you what type of triangle it is, which is very important to us because we shouldn't even need to use Pythagorean theorem when we know that our sides are congruent. We should just know the next side. I'm going to show you the Pythagorean theorem just so I know we're on the same page, okay? We're looking for c, which is over here. So c squared, your hypotenuse squared, is equal to your legs squared plus your legs squared. So when we simplify this, c squared is equal to 9 plus 9. C squared is equal to 18. And in order to solve this, this is where it gets tricky. We need to find the square root because we need not c squared, but c all by itself. So how do we find the square root of 18? Well, factor. 9, 2, 3, 3. Okay? So here we end up with the square root of, circle your primes, 2 times 3 times 3. We could look at this in one of two ways. Remember, we could look at it as the square root of 2 times the square root of 9. We could look at it as a group of 2, so we could take it out. Okay, but when this reduces right here, the square root of 9, we are going to get 3. And we do not know the square root of 2. So our solution is 3 square root of 2. If you guys look and you paid attention in class, you should have known before that you're going to take the measure of your leg and multiply it times the square root of 2, and that's going to be your width. Okay, right there. 3 square root of 2. Okay, so we found that one. Now down here we are going to have to find our width, right there, or length, I guess you could say, since I already used width. Okay, over here you can see 2 units. We're making a right triangle to find this length. You see how the right triangle encloses the side of your figure. So a right triangle is a 2 by 2. Look at that. I can guess this because I am going to take the side or the leg of my triangle and I am going to multiply it by the square root of 2. If you want me to check that, you're wasting my time. It is right. Okay, so we have 3 square root of 2 and 2 square root of 2. In order to find the area of a rectangle, I'm just going to put rectangle like that, we need to take length times width. Well, we have a length and we have a width, so we are going to substitute them in. So the area of the rectangle, length times width, our length is 2 square root of 2, and our width is 3 square root of 2. Okay? What you need to keep in mind here is that these numbers out here would be considered your whole numbers. Okay? So we need to multiply our whole numbers. 2 times 3, which is going to be 6. We also need to multiply our radicals. Okay? Those are our square roots. We also call them radicals. Okay? And those square roots multiplied together give you the square root of 4. Keep in mind, again, multiplication out here. So the area of our rectangle can be simplified even more. The area of the rectangle can be simplified to 6 times, yes, you know the square root of 4, it is 2. So even though our side lengths are very, very yucky, our area simplifies to something very simple. 12, and we could call them square units. Okay? So this is how multiplying radicals can come in to benefit us in math. We can simplify very, very messy side lengths and create something very beautiful. Yes, that's right, class. Beautiful. Numbers are beautiful. Okay, what if we have 2 figures, 1 graph? Okay, so here's our 2 figures, 1 graph. The area of PQRS is what percent? Ooh, you guys are really struggling on these ones. Okay, remember is equals what percent W sub P of is multiply. So we're going to be looking into that after we figure this out. So the first step is to find the easy one. That's always what I like to do, find the easy one. So here we have a square outside. I'll use a different color so you can see what I'm talking about. Talking about DABC or ABCD, however you want to look about it. 1, 2, 3, 4, 5 units. So I'm going to write a 5 there. And over here, 1, 2, 3, 4, 5. Obviously, the definition of a square is that all sides are equal. So we should know that. So we could immediately find the area of A, B, C, D. And it is equal to 25 units square. Okay? Our next job is to find the area of this square. So what are we going to have to do? Well, we're going to have to find the area. We're going to have to find those side lengths. So here, like I taught you in the last one, 1, 2, 3, this is a 3, this is a 2. So here we can't use a rule of 45, 45, 90. So we actually need to go through 2 squared plus 3 squared is equal to C squared. Okay, so we get 4 plus 9 equals C. So we end up with the square root of 13 equals C. Okay, there's one side length. I'm going to write it down, square root of 13. Here we have a 1, 2, 3 by 1, 2. Oh my goodness, the same thing, because guess what's inside? A square. Okay, we could look at this in one of two ways. We could say the square root of 13 times the square root of 13, which is going to be the square root of 169, and you should know the square root of 169 is 13. So this area right here is 13 of PQRS. So PQRS equals 13. The only other thing that I want to point out is that square side lengths could also be looked at as square root of 13 squared. Okay, so this is kind of a new rule. It's jumping a little further than what they're talking about, but what I want you to see is that a square root and a square can cancel. Okay, so the inverse operation of square rooting something is squaring it, just like division and multiplication or addition and subtraction. They cancel each other out. Square root and squaring cancel each other out. So your solution would be 13. Okay? Another way you could have done this as well would be to have found the area of the triangle. Because how many of these triangles do we have? 4 of them. Okay, so we could have found the area of those triangles and subtracted it from the original area. Now that answers the area of each of my figures, each of my squares, but it doesn't answer the question. The area of PQRS is what percent of the area of ABCD. So we need to write an equation here, which is kind of what we've done already this year many times. So we're just going to say this is A, which we know A is 25. 25 is what percent, W sub P, of the area of, so of, the area of, and I wrote that wrong already. Let's change this. PQRS is 13, I apologize. 13 is what percent of 25. So is it going to be smaller or greater than 100? The answer is smaller. That is right. So when we go through this, what are we going to be doing? How do we cancel out multiplication? That's right, with division. So let's check it out. Let's divide them. So we get, and divide both sides by 25. Okay, so I'm going to move down here just so we can see this a little bit better. Okay, we had 13 is what percent of 25, divide by 25, divide by 25. These 25s will cancel, so our what percent, or W sub P, is equal to 13 over 25. Now, is that a percent? No. So what do we need to do to find the percent? We would actually need to, well, we could divide, or we could look at it as this would be times 4, and what does that give us? Well, it gives us 100 in the denominator, which is per cent, right, per cent, and up in the numerator it gives us 52. So what is your solution going to be? It is going to be 52%. So the smaller one is 52% of the larger one. Okay, makes sense? Very good. And your last one is going to be to simplify this radical. I think we're done after this, so thank goodness, right? Sorry, Mrs. Clorn has been long-winded. Square root of 3 times the square root of 12, which I am going to break into 6 and 2, prime number, 2 and 3. Okay, so we're going to have 2 times 2 times 3. So we could actually separate each of these if we wanted to. Square root of, or combine them I should say, square root of 2 times 2 times 3 times 3. Because when we combine them, doesn't matter, they're all under a radical, we get groups of 2. This is looked at as the square root of 4. This is looked at as the square root of 9. Do we know the square root of 4? Yes, it is 2. Do we know the square root of 9? 3. So our answer is 6. We could also take out groups. So here I could have taken out a 2, and I could have taken out a 3, and I would have gotten 6 right away as well. All right, we do have one more. I am so sorry I tricked you, but I think you are going to want to see this. The square root of 42, we are going to factor 2 and 21. 2 is prime. 3 and 7. Okay, those are both prime. Remember, this is multiplication in here. Let's go with 6 and 4. This one will be 2 and 3, prime and prime. This one will be 2 and 2, prime and prime. Now, when you rewrite these prime numbers, write them in order because it makes it a lot easier. So we're going to have 1, 2, 3, 4 2's. They're all being multiplied. Don't forget that. We have 2 3's. And we have a 7. Remember, this is your 2 is your index number, okay, because it's the square root. So that means this is 2. So we can take groups of 2. Okay, over here I'm going to show you the last way I did last time first. So if I take out a groups of 2, I can take out these digits. 2 times 2 times 3, because I took out a 2 for that one, a 2 for that group, and a 3 for that group. And then left underneath is the square root of 7. So this ends up being 2 times 2 is 4 times 3 is 12 square root of 7. You could also look at it as, I'll show you the first way I did last time, the square root of 4 times the square root of 4 times the square root of 9 times the square root of 7, because they can be combined into separate radicals. This would be 2 times 2, remember multiplication in between each of these, times 2 times 3 times the square root of 7, which ends up being 12 square root 7. What is this called? Simplified radical form. All right, that's all for today. Make sure you get your practice set problems done before you come to class, okay? Practice set problems done before you come to class.